What is the difference between a kibibyte, a kilobit, and a kilobyte? This question got me wondering about the differences between these three ways of measuring size: a kibibyte, a kilobit, and the conventional kilobyte. I understand that these measurements have different uses. Data transfer rate is measured in bits per second, but I'm not quite sure if I can tell the difference between MB and MB and MIB. Here is a comment, reproduced below, taken from this answer, emphasis mine. The C64 has 65,536 bytes of RAM. By convention, memory size is specified in kibibytes, data transfer rates in kilobits, and mass storage in whatever the manufacturers think of now bytes. Hard drives use T, G, M and K on the label. Windows reports the size in T, G, ME and K. And those 1.44 MB floppies? Those are neither 1.44 MB nor 1.44 MIB, they are 1.44 kilokibibytes. That's 1440 kib or 1'474 560 bytes. Dash third. It's the same way with any C prefix. K, 1 by 103, M, 1 by 106, G, 1 by 109, so by extension. The only ones that are a bit different are the IEC binary prefixes, kibi/mibi/gibi etc., because they are in base 2, not base 10. For example, all numbers equal 2 something instead of 10 something. I prefer to just use the C prefixes because I find it to be a lot easier. Plus, Canada, my country, uses the metric system, so I'm used to, for instance, 1 kilogram equals 1000 grams, or 1k anything equals 1000 base things. None of these are wrong or right, just make sure you know which one you're using and what it really equates to. To appease the commenters. This is why, if you've ever taken a look in a hex editor, everything is split into 2 hexadecimal characters. Each hex character is the size of a nibble, and there are 2 to a byte. For instance,
there are a few basic terms that are simple and easy to understand. To convert between bits and bytes, with any prefix, just multiple or divide by 8, nice and simple. Now, things get a little more complicated because there are 2 systems of measuring large groups of data, decimal and binary. For years, computer programmers and engineers just used the same terms for both, but the confusion eventually evoked some attempts to standardize a proper set of prefixes. Each system uses a similar set of prefixes that can be applied to either bits or bytes. Each prefixes start the same in both systems, but the binary ones sound like baby talk after that. The decimal system is base 10, which most people are used to and comfortable using because we have 10 fingers. The binary system is base 2, which most computers are used to and comfortable using because they have 2 voltage states. The decimal system is obvious and easy to use for most people. It's simple enough to multiply in our heads. Each prefix goes up by 1000, the reason for that is a whole different matter. The binary system is much harder for most non-computer people to use, and even programmers often can't multiple arbitrarily large numbers in their heads. Nevertheless, it's a simple matter of being multiples of 2. Each prefix goes up by 1024. 1k is 1024 because that is the closest power of 2 to the decimal k of 1000, this may be true at this point, but the difference rapidly increases with each successive prefix. The numbers are the same for bits and bytes that have the same prefix. Notice that the difference between the decimal and binary system starts small. At 1K, they're only 24 bytes, or 2.4% apart, but grows with each level. At 1 gram, they are in GT, 70 MIB, or 6.9% apart. As a general rule of thumb, hardware devices use decimal units, whether bits or bytes, while software uses binary, usually bytes. This is the reason that some manufacturers, particularly drive MFGs, like to use decimal units, because it makes the drive size sound larger, yet users get frustrated when they find it has less than they expected when they see Windows at OW! Report the size in binary. For example, 500 GB equals 476 GB, so while the drive is made to contain 500 GB and labeled as such, my computer displays the binary 476 GB, but as 476 GB, so users wonder where the other 23 GB went. Drive manufacturers often add a footnote to packages stating that the formatted size is less, which is misleading because the file system overhead is nothing compared to the difference between decimal and binary units. Networking devices often use bits instead of bytes for historical reasons, and ISPs often like to advertise using bits because it makes the speed of the connections they offer sound bigger, 12 MIPS instead of just 1.5 MIPS. They often even mix and match bits and bytes in decimal and binary. For example, you may subscribe to what the ISP calls a 12 MB/s line, thinking that you are getting 12 MIPS but actually just receive 1.43 MIPS, 12,000/8/1024/1024.
If you want to support the channel, please consider subscribing.